Welcome to lesson 18. This is multiplying three factors and missing numbers in multiplication problems. So this is definitely an important lesson that I want you to pay attention to because I've definitely seen struggles in the past and misconceptions when multiplying by three factors. One misconception that I've seen in the past has been that when we have three factors that we're multiplying is that I'm going to multiply all three of these together. Or maybe I'm going to do 8 times 7 is 56, and 56 or 9 times 8 is 72, and then add those together or multiply those together. Either way, your answer will be incorrect. So you do need to pay attention to how to solve three factors in a multiplication problem. One thing that we do know from the commutative property of multiplication is that we can multiply in any order. So the order of how we multiply does not make a difference. I can start with 9 times 8 first, or I can start with 8 times 7, or I could even start with 9 times 7 first. Whichever you choose or whichever you decide, you just pick two at a time. So with 9 times 8, I get 72. Since I've already found the product of these two numbers, I don't need to multiply them anymore. I then need to multiply 72 times my last factor, which is 7. So when I multiply 72 times 7, we'll go ahead and solve that together. I multiply by 7 times every digit, just like we learned in the last lesson. 7 times 2 is 14. I'm going to carry my 1 in the tens place. Bring down the 4. 7 times 7 is 49. Plus 1 is 50. So my answer to 9 times 8 times 7 is 504. If I were to start with 8 times 7 and do 56 times 9, or 9 times 7 and do 63 times 8, my answer will still be the same because that's what the commutative property of multiplication says. So we're going to go ahead and start with example 1. I would like you to go ahead and try it in your spirals first. So I'm going to go ahead and start with 3 times 5, just to change it up as far as the order of which numbers we're multiplying first. And I know 3 times 5 right off the bat is 15. Then I'm going to do 15 times 6. Because that's the last factor that I now need to use. So 15 times 6, I'm going to do 6 times 5 is 30, carry my 3, bring down the 0. 6 times 1 is 6, plus 3 is 9. So the product of 6 times 3 times 5 is indeed 90. Again, if you were to have started with 6 times 3 first is 18, and 18 times 5. Or if you were to do 30 times 3, your answer will still be 90, as long as you solved it correctly. All right, example 2. I want you to, again, go ahead and try this on your own. This is 5 times 7 times 12. What I would recommend, though, with first is that multiplying 12 times 7 first or 12 times 5 first, because we've only learned how to multiply by other one-digit numbers. So if I'm multiplying 35 times 12 first, we haven't learned that yet. So unless you remember that from last year, it'll be fairly difficult and you could end up with the wrong answer. I'll go ahead and start with multiplying 12 times 7 first. I'll go ahead and solve that out, even though I know that in my head. I know a lot of us still need to see it for the visual learners, and I know I wouldn't expect all of you to have your 12 factors of 12 memorized, or the products of 12, so it would be 12 facts. 7 times 2 is 14, 7 times 7 is 1, plus 1 more is 8, so I have 84, and I'm going to do 84 times 5. 5 times 4 is 20. I'm going to carry my 2, bring down the 0. 5 times 8 is 40, plus 2 more is 42. I know it's a little scrunched, but my product of 5 times 7 times 12 is indeed 420. Our next example that we are going to look at is example 3. Now, this kind of is a visual of 3 factors in a multiplication problem. Now, how we are going to approach this is we're going to create a multiplication problem to find how many blocks would be in this rectangular solid total. So what I'm going to look at is that if I were to look at just this surface right here, I know I have 2 rows, 1, 2, and I have 3 in each row. So that's already a multiplication problem. That would be 3 times 2. Now I have 2 surfaces of these. So if I'm looking at maybe this block, and this block, I'm looking at this whole front side of the solid. So these are the blocks I've already considered, I've already counted. If I do 3 times 2, that's finding this side. However, I have a whole nother layer added to it. So I have 2 layers of this set right here of 3 times 2. So I'm going to multiply by another 2. So that's how we end up finding how many blocks would be in this rectangular solid total. So 3 times 2 is 6, and 6 times 2 is 12. This one is fairly simple because we're dealing with much smaller numbers. So I would have 12 blocks altogether. Example 4. Now this is where we're going to get into missing numbers in multiplication. So our missing numbers in multiplication, I'm going to have a number times 3 equals 18. So what number times 3 equals 18? This is when multiplication facts, again, are very important to know. It's only going to keep building as far as if we don't know our multiplication facts, or if we can't get them fairly quickly and fairly accurately, then this is going to get more difficult. So this is just the beginning. This is just the easy part of what times 3 is 18. And I know for a fact that 6 times 3 is 18, so W equals 6. Now letter B, this shows us another way of how missing numbers in multiplication problems look like. Now this is actually very foundational for algebra, which is very important to remember, and I know we don't see it often, but you won't actually see this kind of problem often at all. You're going to always start to see it like this. 3n, this means 3 times n. Whenever you have a missing number right next to a number itself, they are factors. They are being multiplied together. That's always going to be a case. So if you don't ever see a sign, if you don't see a multiplication sign, if you don't see a division sign, addition, or subtraction, you can automatically know and assume that it is multiplication. So that's always your go-to. You really need to make a mental note of that. 3n, so 3 times what number equals 24? Well, I know out of my multiplication facts, again, this is by memory, that 3 times 8 equals 24. So n equals 8. So that's how you go about solving those problems. Again, if you have a letter right next to a number and there's nothing in between them, then it's multiplication, always. All right, this is the practice set problems that I want you to do. This is letter B, 10 times 9 times 8. Letter D, 4 times 3 times 2 times 1 times 0. Letter F, 5m. Again, this is multiplication. 5m equals 30. You're solving for m. And letter H, it's kind of a comparison, but you're finding a missing number. 3 times 4 equals, you need to know what this part equals, and then 2 times n needs to equal the same thing, so you need to figure out what is n supposed to be. All right, that's the end of lesson 18, multiplying 3 factors and missing numbers in multiplication. Thank you for listening.